Good morning, everyone. My name is Brad Schmidt. I'm the Global UAV Sales Manager. Certainly welcome, a very warm welcome to our webinar this morning on Post-Processed RTX for UAV survey and mapping. So wherever you may be joining us from, good morning, good afternoon, good evening. We're very pleased to be able to take you through this fourth in our webinar series on turning your UAV into a professional mapping solution. This morning, I'm joined by Nithin Kumar, who's basically from our product support department. He's a product support analyst and will be helping me with the webinar this morning. I'm also joined by River Kim, who is basically going to be handling the questions section of the webinar. So there is a questions box, which you'll notice on your screen. And please, as we go through and the webinar, as questions come to mind, please enter those in the question box and we'll address those at the end. So just a couple of things here before we get started with the details. This is, as I say, the fourth in our webinar series. The first one was actually on direct georeferencing for UAV surveying and mapping. We've also done a webinar on Applanix UAV augmentation solutions, as well as we took a look at our direct georeferencing as a service offering. You'll find these webinars on our website. They're actually under the news and blog section. So certainly if you haven't seen those, I would encourage you to go and have a look at those, as they provide some very useful information as well. This particular webinar is a deeper dive into something we've introduced before, something called RTX, Trimble RTX. And we're going to take some time to just kind of unwrap or unpeel the onion on this and take a good look at what PP-RTX can do for UAV survey and mapping. Okay, just a couple of housekeeping items before we get started. So as the webinar mentioned, everyone is currently on mute. We will be recording this. We are recording this webinar, and we will be following up with an email to you with the link to where you can actually view the webinar. And if there's some questions at the end that we're not able to get to, we'll certainly provide a follow-up with written answers for those. So we certainly do, as I say, encourage you to write your questions in the questions box, and then we will get to those at the end of the webinar. Now, also, if you're having any problems hearing the sound or video, we have our team from part of our marketing team has joined us. Cynthia and Sarah are online. You can simply enter your concerns into the chat box, and they'll try to sort that out as we go through this webinar. So as I say, my name is Brad Schmidt. I'm the Global UAV Sales Manager, and Nithin Kumar is joining me to help with this presentation. Our format is typically a 20-minute presentation, and then we reserve about 10 minutes for questions at the end. We try to keep this to roughly 30 minutes so we don't take too much of your day, but provide you with enough information to maybe take away and consider for possible implementation into your UAV programs. So if I could have the next slide, please. So our agenda today, we'll be taking a look at what is Trimble PP-RTX. So we're going to take a good look at that and define that for you. Take a look at how it works. We'll take a look at PP-RTX used for UAVs and how we use PP-RTX to perform our direct georeferencing. So we're going to get into that. We're also going to take a look at the best use of PP-RTX. What are those scenarios out there that can really take advantage of this technology when you're doing UAV survey and mapping? And so there are some cases where PP-RTX stands out exceptionally, and so we'll take a look at those. Of course, you can use it for many different types of UAV survey and mapping missions for your corrections. We'll take a look at some comparative methods, which we're going to walk through some examples essentially, if you will, and then we'll wrap up with our questions at the end. So I think our next slide is a poll. Is that correct, Cynthia? Yes. So just before we get started, we thought we'd conduct a quick poll. So our poll is, what method do you currently use to correct your UAV data? So the typical methods are physical base station, very, very common. There are individuals out there using virtual reference networks, such as CORS networks. There's the Trimble PP-RTX service that we're going to talk about today specifically. There may be some other correction methods that you're using, or maybe you're not using anything at all. So we'll just give everyone a chance to respond to the poll if you like, and then we'll take a look at the answers that we get, and then we'll dive a little bit deeper into PP-RTX. So, Cynthia, how is our poll coming along?
Our poll is looking good so far. We've got most of our responses in. I can close it up.
Okay, let's, in the sake of time and prudence here, let's just close this up and we'll move forward. Take a look at the results.
Yep, so we've got 50% for physical base station, 10% for virtual reference stations, 12% for Trimble PP-RTX, 7% for other, and 21% for nothing.
Okay, very good. So that's kind of along the lines that I would have expected, 50% for a physical base station. That is the most common method, and it is very practical and certainly very useful for UAV surveying and mapping. So, but let's take a look at how the technology, our PP-RTX technology, is emerging and how that can bring value to the UAV surveying and mapping industry. So at this point, I'm going to turn it over to Nithin, who's going to walk us through the technology.
Hi everyone. Thank you very much for the introduction, Brad. Hi everyone, my name is Nithin Kumar. I'm a support analyst here at Applanix, and I work to ensure that our customers are getting the most of their Applanix products. So I'll be taking over the presentation from now, and I'll be speaking on what exactly PP-RTX is. So before we can talk about what post-processed RTX is, we must first talk about what real-time center point RTX is. It's a real-time GNSS correction service developed by Trimble, and it works similarly to virtual reference station technology in that it uses a dedicated network of base stations across the globe that track GPS, GLONASS, Beidou, QZSS, and Galileo. It's certified with a data integrity layer to ensure that the final product is correct and accurate, and also to ensure that the uptime is reliable. So this speed and accuracy is what makes it a real-time solution that can be used for critical response applications or real-time automotive applications, to list a couple of examples. Centerpoint RTX can also produce accuracies approaching RTK, all without any local reference station or any local service provider's broadcasts. So how does it work? I briefly mentioned on the last slide that RTX works similarly to other virtual reference station technologies. So if you're familiar with POSPAC's SmartBase, that's another example of a VRS. Trimble operates well over 100 base stations across the globe, tracking multiple GNSS constellations. These observations are then passed to Trimble's control center, where GNSS corrections are determined for the entire globe using Trimble's models. The corrections are then relayed to customers using different methods, such as IP or cellular broadcasts, which you may be familiar with. But more popularly, the corrections are also broadcast via satellite directly onto the onboard receiver. That means that users don't need to have any internet or cellular setup. They can receive the corrections simply by turning on their system. Convergence times. So RTX is different from other differential GNSS methods in that it does not difference out atmospheric errors. Rather, these errors are reduced using Trimble's atmospheric models for the entire globe, along with more regionally calibrated models. The convergence time is a function of a few key things. The type of antenna and the overall installation is important. And I will mention that all Applanix antennas are RTX capable. Also, how well satellites are being tracked, as in how clearly they are being seen and how well spread out their geometry is in the sky, is important. But in UAV applications, open sky is typically a given, and satellite coverage should always be good. So this all results in the following lead times. Standard RTX, which uses a general global atmospheric model, has a convergence time of 15 minutes. Fast RTX, which uses specific regional models, has a convergence time of less than 5 minutes. So that means from the time the receiver is turned on and starts tracking satellites, it can start producing accurate results within 5 minutes, which is very fast. Here in this slide, we can see highlighted the regions where fast RTX is available. So this is where you can get convergence times of less than 5 minutes. The reason being that these highlighted regions just have a dense enough network of stations to produce high accuracy estimates of atmospheric delays. And the mainland US and Europe just have existing networks of base stations that are quite dense. But as other parts of the world build more dense networks, fast RTX should be able to operate there as well in the future. Okay, so now that we have a basis of understanding for what real-time center point RTX is, we can begin discussing Applanix's post-processed or PP-RTX. Now this will likely be more relevant and useful to most people here today. Okay, so far I've spoken about using RTX to generate an accurate solution in real time while the UAV is up in the air. However, it's rarely the case that a UAV operator needs the navigation solution to be accurate while in the air. It's really only important that the final solution be accurate later on while we're generating mapping products. That is why we developed PP-RTX or Post-Processed RTX, which allows POSPAC to generate an accurate solution all without base stations. So this is a subscription service that is cloud-based. It does require an internet connection while processing. And it applies the same forward and reverse processing steps that POSPAC users may be familiar with. Solutions can be generated as quickly as 5 minutes after a mission is flown. And it can produce accuracies of 3 centimeters RMS in the horizontal and 6 centimeters RMS in the vertical. Now that's just 1 centimeter off of the accuracy of the solutions that can be generated using a physical base station. Here we can see some situations where PP-RTX can be very useful. Specifically, these are situations where it would be difficult to set up your own base station because the area is hard to access, or if you may fly out of the range of a base station, such as with corridor or coastal mapping, or if it may be time-consuming to set up a base station multiple times, such as when you have multiple short flights over a large area, for example. How it works. So it is based on the Centerpoint RTX technology discussed in the earlier part of this presentation. So we know that the corrections are generated by the observations of those 100 plus base stations across the globe. Flight data is then uploaded to Trimble's RTX servers, and then GNSS corrections are then downloaded for the flight. Now for a POSPAC user, this is all done with a single button click. Then POSPAC uses its standard infusion algorithm to resolve integer ambiguities, combining forward and reverse solutions, and finally producing a high accuracy navigation solution. And again, since this is post-processing, there is no convergence time within the data itself. So what's required is a POSPAC UAV license and a subscription to PP-RTX. And internet connection will be needed as well. We also require a minimum amount of time for APX data logging for optimal results. This means that the APX needs to be logging in open skies for a minimum of 30 minutes in standard RTX areas, or for a minimum of 10 minutes in fast RTX areas. Now the APX does not need to be flying for this entire time, but as long as it is logging with the antenna tracking satellites, then that's okay. And of course, with any flight, we also need clean GNSS observables. In UAV settings, you should have no problem seeing plenty of satellites in the sky with clear signals. Finally, a compatible antenna is also needed, again, which all Applanix antennas are. Okay, so here's just a visual workflow for what was described in the last two slides. You would first load your trajectory info or APX files into POSPAC, and then that would be uploaded to the RTX servers. POSPAC would then download the RTX corrections and run the GNSS processor for these corrections, along with the APX's observables. Then the APX's IMU data is introduced when running the RTX inertial processor to produce our final positions and orientations at 200 Hertz. So this process should be familiar to POSPAC users. The only difference here is that you're using the RTX servers instead of your own physical base station or a CORS network. And again, you can access the RTX servers with a single button click within POSPAC. Okay, now we'll briefly discuss in more detail some of the benefits of PP-RTX. Here in point number 1, we can see that using PP-RTX can greatly improve efficiencies, specifically by reducing the amount of time it takes to generate our solution from the very start of the process to the very end. Here we're comparing the time required to operate with a local base station, or LBS, versus with PP-RTX. We can see that PP-RTX can save time because it does not require the setup or operation of a base station at the start, or disassembling it and doing any QA on the base station data afterwards. Also, POSPAC does not need to decode or process the base station data, which would save time. Point number 2, PP-RTX can also produce very accurate results within the 3 to 6 centimeter RMS error range. And that's available anywhere in the world at any time. Point number 3. So PP-RTX not only can reduce the amount of time it takes for data collection in the field because you don't require a base station, but the final solution is also available very soon after the flight is complete. So less than 10 minutes after the flight, and very regularly within 5 minutes afterwards, you can generate an accurate solution. However, with your own base station or with publicly available base station data, you may have to wait hours or even a full day for ephemeris data to become available. The final benefit that we'll discuss is that PP-RTX simplifies the collection of data that is not close to a base station. So traditionally, you would need to operate within 20 kilometers of a base station, which may be difficult if you rely on publicly available base stations, or if you have a long or large area to map. But since PP-RTX does not require a base station at all, that's something you don't need to worry about at all. Now we'll discuss some of the limitations of PP-RTX. Now it works optimally with fully open skies and with clear satellite visibility and minimal multipath. Now that should be easily achievable for airborne applications and UAV users. But if you're a terrestrial user, you may not get optimal results. Fast RTX is limited to certain parts of the world. As we saw, that was the US and Europe, but that is expanding all the time. And outside of fast regions, you can still generate an accurate result, but you will need 30 minutes of logged data. And finally, the accuracy of the vertical position of PP-RTX is not yet as good as when a local base station is used. The local base station can produce accuracies of 5 centimeters RMS, while PP-RTX can produce 6 centimeters RMS. So again, we're off by just 1 centimeter there. Okay, so now we'll actually take a look at our most commonly used processing methods and see how PP-RTX stacks up to them. We'll have a look at accuracies generated by single base, where you use just one physical base station, smart base, where you use a CORS network, a combination of single base and smart base, and finally, we'll compare those to PP-RTX. And this will all be done with one fixed wing flight example that we have for you here today. Okay, so here's our flight demo for our single base example. We started at an airport, we flew to our area of interest and then returned, as you can see on the screen. We set up a base station at the airport, which will generate our single base solution for us. However, this is limiting because the project area is 55 kilometers away. So this is outside of our optimal 20-kilometer baseline, but we will rather expect to see reduced accuracies slightly. Now our options for solutions here are to add another local base station closer to our area of interest. However, this will be time consuming and expensive. We could try a publicly available cores network, or we could try PP-RTX. For now, let's have a look at using a cores network to generate a smart base solution. Now we'll see the same flight, but this time we're using a network of local base stations to produce a smart base result. So you can see it's the same flight, and surrounding it is our cores network. Here, we're limited by the network of publicly available data. And unfortunately, the distance between base stations is well over 150 kilometers, which will not really produce optimal results for us. So now our options for solutions are adding in our own dedicated base station again, but again, this would be time consuming and expensive. Or we can try PP-RTX. But let's just see what it would look like to add in our own dedicated base station. Okay, so here we have an augmented smart base solution. So this is simply a combination of our original single base station at the airport plus our smart base network. But now since we have such a dense network of base stations, we can actually expect the highest level of accuracy. However, it would normally be very impractical to always have to determine an optimal network and set up our base station to create that network in the field for every project. So our final and most practical solution to counteract that is to generate a PP-RTX solution. Okay, so at this point, we have run the flight 3 times using single base, smart base, and single base plus smart base. Now we'll have a look at how those positions for these compare with PP-RTX. Okay, so now we'll move on to analyzing the results. Here we'll have a look at how PP-RTX compares with our single base solution, which was the first one that we looked at. So this plot represents the difference in the positions determined by PP-RTX and by single base over the course of the flight. So the x-axis here represents the time of the flight, and the y-axis is the difference in positions determined by our 2 methods. We'll specifically be looking at the agreement between the 2 at the 95% confidence level. Here we can see that at 95%, the separation is over 7 centimeters in the vertical alone, and also over 3 centimeters and 2 centimeters in the north and east. So that's quite large. So let's just quickly flip over to the next slide to have a look at why that might be the case. Okay, so here we can see that the single base solution actually has issues with it. This plot on the right here shows us that the final single base solution did not have good agreement of the ambiguities in the forward and reverse passes. Now I won't get into the details of interpreting this graph, but all of this is to say that even though single base is likely to produce a high accuracy solution in most cases, base stations are still susceptible to issues and failure, whether it be operation failure or hardware failure. Okay, so now let's move on to comparing our PP-RTX solution with SmartBase. We see now that we have better agreement between the 2 results. The vertical difference is now down to less than 7 centimeters at the 95% level. Even the horizontal component is lower too. However, these values are still a little high. They're above 5 centimeters, and we'll use 5 centimeters as our threshold because that is how accurately POSPAC can estimate vertical positions at the 5 centimeter level. Okay, so finally, we'll have a look at how PP-RTX stacks up against SmartBase plus single base. So if you recall, this was thought to be the most accurate solution because we had such a dense network of base stations. Now we can see that PP-RTX gives us the most agreement in positions. The vertical position is now less than 5 centimeters at the 95% level. And again, we're using 5 centimeters as our acceptance level because that is how accurately POSPAC can estimate positions too. So this tells us finally that PP-RTX stacks up pretty well against our other processing methods when it comes to accuracy. So we've seen so far in the presentation that PP-RTX can save us time and money during the collection of data because we don't need to set up our own base stations. It can also help us in post-processing because we don't need to rely on publicly available base station data But now we're seeing that we can get those benefits without really having to sacrifice accuracy all that much, if at all. So PP-RTX can reliably produce very accurate results, which makes it a really great option for UAV users, especially in the long run. So with that final bit of analysis, I'll pass it back to Brad.
Great, thank you very much, Nithin. That was a very good summary of what PP-RTX is all about and what it can do. So we're going to open it up to questions now in the questions box. So if you could please enter any questions that you may have, we will answer those questions, and then after that, I'll do a quick wrap up at the end, and we'll finalize our webinar for today. So at this point, let me turn this over to River. River, do we have any questions right now?
Yep, we have a few questions. I could get started with the first one here. So
Sure.
Our first question is, during flight, if RTX is not getting corrections from the server, then what do we do? I think maybe we can explain what the difference between Trimble RTX and POSPAC PP-RTX is for this question.
Yeah, that's a good question. And there is an important point here that we need to separate real-time RTX and post-processed RTX. So this presentation was on post-processed RTX. And to use post-processed RTX, you do not need to have any real-time setup. You don't need to have corrections being streamed into your APX while it's flying. You can simply collect flight data the same way you would if you are using a physical base station. The difference only appears later on in POSPAC when you begin post-processing. And PP-RTX will always be available 24/7 across the entire globe in post-processing. If we're speaking about RTX not being available in flight, then that's kind of another topic that we won't really be discussing today. But that would essentially involve some troubleshooting of our GNSS connection.
Okay, we have another question that's asking if the photo events can be displayed on these error plots.
Yes, they can. That's a POSPAC question. But yes, you can display the exact time that a photo event was taken on these plots. For example, the one that we're looking at on the screen right now. That's very useful in troubleshooting because we can see what the errors are specifically when an image is taken, not just while we're ferrying to our job site, for example.
Okay, next question is, if you're using PP-RTX, does that mean our flight control system has to use a Trimble GNSS receiver?
Very good question. PP-RTX is only available within POSPAC, and POSPAC only supports Applanix hardware. And Applanix hardware only uses Trimble's GNSS receivers. So the long answer to that question, or the short answer rather, is that yes, you do need to be using Applanix hardware, which uses Trimble receivers, to use PP-RTX. It will not be available to non-Applanix hardware.
Okay, we have another question here. How should you report the accuracy of the PP-RTX solution where you have no ability to collect ground control in the survey area or nearby? Is there any best practice to remove or reduce any bias in the solution?
Yeah, that's a good question. PP-RTX is somewhat similar to RTX in that the antenna and the installation must really be accounted for. So as I mentioned, the antennas sold by Applanix do support RTX, but the installation, we need to ensure that our installation parameters are correct, as well as ensure that we're shielding our antenna from any sources of interference on board or on the ground. Other than that, to answer the first part of the question, there's no way to ever do an absolute comparison of accuracies unless you have ground control points. The accuracies that we discuss here in POSPAC, for example, being within that 5 centimeter threshold, that is how accurately our navigation solution is estimating. It's not actually being 5 centimeters away from the true position that an image was captured.
Okay, that seems to be it for the questions. We do have some that are pretty specific for certain users, which I think you can reach out to after Nithin.
Sure, sounds good. And as Brad mentioned, if anyone does have any questions, they can enter it in and we can provide written answers to them afterwards.
Yes, we'll definitely follow up with any questions we didn't answer here, or to those people who have very specific questions, we'll follow up separately with you. No problem on that. Okay, well, actually, we're right at the plan mark that we had reserved for today, 30 minutes. So it's 11:30 here in the Eastern time zone. So we're going to wrap things up. I just want to let you know how you can get additional information. So first of all, if you want to learn more about PP-RTX, you can go to our website, www.applanix.com. We have a lot of information there for you on this. Also, if you want to reach out for some more specific information about your particular circumstances, you can reach out to our sales team at sales@applanix.com, and we'll basically get back to you with some answers to your questions. And certainly on that note, I just want to thank everybody for taking the time today, taking the 30 minutes out to spend with us. Hopefully it was informative. Hopefully you're able to learn a few things about PP-RTX and the value that this can bring to UAV surveying and mapping. So I think as the technology continues to improve, I think we'll see, just kind of linking back to our poll, that more people will start to use some of these virtual services that can provide this kind of time and cost savings. And that's really where we're trying to get to with PP-RTX and what we're offering with our PP-RTX solution, which we have a number of people, quite a number of people actually using right now. So on that note, on behalf of our team, on behalf of Nithin and River and Cynthia and Sarah and myself, thank you very much, and we look forward to seeing you again on another one of our UAV webinars on turning your UAV into a professional mapping solution. Yeah, so we'll see you in the future. Thank you very much. Bye-bye.